Welcome. I think lecture number 39, I think most probably, part 2. See the title. I forgot to tell you one thing. When I started examples, you keep, when those who are preparing your own notes, because in the notes when I write all headings correctly, what is going on, etc. So what you do is, in the beginning, I started with, see, point load, center, eccentric, etc. At that time, you write title first, heading, simply supported beam with vertical point load, just one point load. Okay. Then afterwards, see the further questions. I started UDL. Right there. Simply supported beam with UDL. There. First subheading, you write UDL for entire span. Solve the questions, what I solved. Then I solved question, if you remember, see, once UDL is here, see, today UDL is in the middle portion. So there you start writing title, simply supported beam with UDL, or write partial UDL. Then some questions has got W and L, some has got numerical, you work out everything. So today's title will be simply supported beam with partial UDL continued. One more note you can make. First we considered full span UDL. Then we continued, after that is over, we considered UDL starting from left end and extending for some length. Bookwork type questions, numerical questions, all solved. Then next I solved, see, this is partial UDL. UDL starting from right end and extending for some length. This already over. Question number 15 last time. Now continued. So question 16 will be once again simply support beam with partial UDL. You can make a note. UDL not starting from one end. UDL somewhere in the middle, inside portion. Either side gaps are there. Means, see, general case. It will start somewhere here, end somewhere here. There is a gap here, there is a gap here. You write that one. Okay, now start. Question number 16, I dictated. See, correctly question you have to write. A simply supported beam of span L is loaded by an UDL of intensity W per unit length for a length of S. See, S means loaded length S, and comma, which is placed symmetrically with respect to center. Make a note in the question, loaded by UDL of W per unit length for a length of S, which is placed symmetrically with respect to center. In the bracket, make a note, S is less than L. If S is equal to L, it will become full UDL. Okay, now start. Usual statement, I will not waste time on this statement. This I have written for all previous 15 questions. VA vertical reaction, VB vertical reaction. Draw a neat sketch. Okay, see here. W per unit length. Now, let it be center of span. This is L. UDL is W per unit length for a length of S. See, given in the question, UDL is symmetrically placed with respect to center of the beam. So let center of the beam be C. C is center. So symmetrically placed means if this is S, this will be S by 2. This also S by 2. S by 2, and the center of UDL will be at L by 2 and L by 2 from here. See, symmetrical placing means from center, how much length that side is how much length this side. Write this statement. Okay, now start. Sigma m about A equal to 0 minus VB into L plus, see here, we want total load acting here. Total, this first of all, this is over many times. So total load. W into S is the total load. Center of UDL is exactly at center of the beam. So directly into L by 2 equal to 0. You will get VB equal to WS into L by 2 by L by 2. VB into L, not L by 2, VB into L by, actually what happened is, I thought I am writing moment of that load. This is called a print mistake, okay, minus VB into L, because answer is L and L will cancel, WS by 2 is the answer, VB. Next, sigma, don't see this one. This is the final result. Don't see this side now. Continue here. Sigma V equal to 0. VA plus VB minus W into S equal to 0. Substitute VB equal to WS by 2. VA also will come WS by 2. Therefore, now after this one, you come here. Therefore, for the beam here, if I call this as AB, C is the center, you mark here. C is the center of the beam, right? Center of the beam at L by 2 here. Load place here. Further you can write here if you want. See, loaded length is S to make more clear. This is center. This is S by 2. Space problem. Okay. Write neatly. This also S by 2. And one more thing you require. Loaded length is S. And this S. And center of the beam from both sides is L by 2, span L, reaction is WS by 2. Now, make a note. After everything is over, make a note. Class, you have actually unnecessarily wasted your time, because this is a perfect symmetrical case. When perfect symmetrical case is there, one line answer. Due to symmetry, your VA upward equal to VB upward equal to total load on the beam in the downward direction. Why? Reaction is equal to action in opposite direction. Divide by 2. Total load is W into S is the total load. Divide by 2, we get same answer right there. Now, long back it happened in my class. When I told, see, just make a note here, just one note. This is a note you make here. Note. When I took moment about A, I wrote minus VB into L plus W into S into L by 2. Someone told me earlier, sir, so far you are not doing that way, sir. Then what I was doing? Sir, you are doing, when you take moment about A, total load into this gap plus half of S you are writing. Yes, I told, correct. So, can we do that way? I will tell what happens if you do that way. Okay. So, just to change it. See, this statement you change now. W into S is the total load into, I want this distance. This is L by 2. This is S by 2. So, what happens now? Or if I mark this way, you can write what here? See, note. Instead of writing L by 2, you can write moment about this point. See here. This is L by 2. This is S by 2. So from here to here will be L by 2 minus S by 2. L by 2 minus S by 2. Okay, correct, sir. And then plus S by 2. Plus S by 2. Right that way. He told, okay, sir, clear. Then I told him, if you do this way, people will laugh at you. Basic principle is moment about M is total load into distance of line of action of the total load from this point. Since if it is unsymmetrical, yes, then you require this gap. It is directly given, symmetrically placed. So, total load into the symmetrically placed means resultant of the total load which passes to center of UDL should coincide with center of the beam should be L by 2. Or see here, L by 2 minus S by 2 plus S by 2. Once again, answer is L by 2. But for you, I will tell, if somebody laughs at you, you write it, seeing my class, somebody may laugh at you. He may tell, what is this, man? Directly given. In return, you also laugh at them. That's all. Laugh at them and tell them, I wrote because in the class Sir wrote it. He wrote it. Just to understand purpose. I also know it. Sir also told in the class that directly you can do it. So it is not for fun. What usually we are doing, he wrote that way. So you also don't get angry with him. If somebody laughs at you, what is this? You tell, this is that. Laugh. You also laugh back. Okay, over. This question over. Now question number 17. Dictated in the class. A simply supported beam. Okay. I'll adjust here now to save the time. Okay. A simply supported beam of span L is loaded by an UDL of W per unit length for a length of, this is L, W per unit length for a length of 3/4 of L, for a length of any some number, 3/4 of L. See, last time it was S. So L and S are separate. Now they are giving in terms of L. 3/4 of L, comma, load is placed symmetrically with respect to center. Okay. Write the question. Write the statement. Now there is no S here. See, when you write here, this length is 3/4, so the more it will come. Okay. No problem. See, now it will move neatly. See here. This is total loaded length is S. L3, this is 3/4 of L, total loaded length. And since they told load is symmetrically placed with respect to center, the center of the UDL is C. Given UDL is symmetrically placed with respect to center, C. Therefore, if that is 3/4 L, you write this distance is 3/8 of L. This also equal to 3/8 of L. Okay. And center is at L by 2, L by 2. Start. Take moment about A. Someone will tell, sir, directly you can get. That we will do later. Minus VB into L plus W into, see here, VB into L plus W into 3/4 L into 3/4 of L is the total load multiplied by from A to center of the UDL is exactly equal to L by 2, equal to 0. Now see here what happens. 3/4 of L into L by 2 is 3/8 of L square divided by L. Your VB will come, red color answer, plus 3/8 of WL is the answer. And those people, suppose someone will ask that laughing part. What is laughing part? Instead of writing into L by 2, right here. This is 3/8 of L. From 3/8 of from L by 2, subtract 3/8 of L, get this distance, then write load into this distance plus this distance. It will come once again L by 2 only. Okay. Therefore, sigma V0, VA plus VB minus W into 3/4 of L equal to 0. VB will come, see, 3/4 of WL. Substitute VB equal to how much? Substitute VB equal to 3/8 WL. 3/8 WL. So, WA plus 3/8 WL minus 3/4 of WL equal to 0. Your VA will come minus 3/4. That side is plus 3/4. This is minus 3/8. 3/4 minus 3/8 is once again plus 3/8 of WL. Now write here. Therefore, new sketch. To understand correctly, write neatly. Therefore, see, if the simply supported beam is here, it's the beam. If you apply a UDL of, okay, little more, W per unit length, which is for a length of 3/4 of L, and center of the center from symmetrically placed center means if this is center from here to here and here to here is 3 by 8 of L, 3 by 8 of L, and then further, one more space not there. Okay, this I can remove now. This I can remove. And then this is from here to here. This is to give complete idea, that's all. L by 2, L by 2. This is L. Then this reaction VA equal to 3 by 8 WL. This reaction VB, I want AB also, no problem, AB. Little dirt is there. VB also equal to 3 by 8 of WL. Right. Now right here, note, actually all this waste of time, little later when you go to strength of materials, at that time, if shortcut is applicable, you go for shortcut. Don't waste time. This is to understand. So right, due to symmetry, total load on the beam equal to W into total load, 3/4 of L. 3/4 of L is the total load divided by 2 will give you 3 by 4 divided by 2 is 3 by 8 of WL. Tell yes, same answer we got. This is question number 17 over. Now I will change over to question number 18. Now see, symmetrical load I told. Now I will go for partial UDL, not symmetrically placed. Little, not symmetrically placed. Some people call it asymmetric, but I prefer the word unsymmetrical. Seen, unseen. Used, unused. Symmetrical, unsymmetrical. English grammar point of view, somebody may tell unsymmetrical, there is no word, it is called asymmetrical. Okay. Understanding important. Unsymmetrical word is more popular than asymmetrical. So, I will use the word unsymmetrical. This is not English grammar class. Over. I will set the question and solve because writing will change. Question number 18 now, correct? I written somewhere here, note, made a note. Where I wrote it? Here. Where I made a note 18. Somewhere I made a note here. Some paper slip or somewhere written. 1 nimisha. 16, 17 over 18, correct? Okay, note. Question dictated. I will dictate the question. Be careful. A simply supported beam of span L is loaded by an UDL of intensity small w per unit length. See, be careful now, small w per unit length, which starts at L by 5 from left end and ends at L by 4 from right end. So, once again I read the question. Simply supported beam of span L is loaded by an UDL of W per unit length, which starts at L by 5 from left end and ends at L by 4 from right end. So, not symmetrical. Okay. Any number can be given in terms of L. Find support reactions. Now, okay, over now. As usual, same story respectively. That Y has gone there because my hand touched it, I think. Okay. Now, VA, VB. See correctly. A, B. See correct, clear now. From here to here is, I will do one thing now, I will put a point C here and D here if you want. Those who want, make a note. A to C is L by 5. B to D is L by 4. They have not given length of UDL. Therefore, that you write here, if you want, length of UDL or which is also called loaded length. I told you that is called loaded length. Loaded length equal to L minus L by 5 minus L by 4. So 1 minus 1 by 5 minus 1 by 4, use a calculator, it will come 11 by 20 times L. That's how I got 11L by 20. Remember, it is not given, you write here, it is not given, it is calculated. Whenever I enter some number in the sketch, which is not given, but we calculated, I usually round it off to show that it is not given. Okay, over. Now, this question can be given in some other way. See here. Or, see, same question. See, if it is L by 5, now you know that this is 11L by 20. They may not give L by 4. See here now. How the question can be given. A simply supported beam of span L is loaded by an UDL of intensity W per unit length for a length of 11L by 20, comma, UDL starts at L by 5 from left end. Okay. Or then, if you want this distance from L, subtract these two, get L by 4. Or they may not give L by 5 here. They may give L by 4 here. And now question will be some other way. See, simply supported beam of span L is loaded by an UDL of W per unit length for a length of 11L by 20, which starts at L by 4 from left end. Sorry, L by 4 from right end. Okay, then you can get this one. But actually, our question they told L by 5 here, L by 4 here, this is not given. So this is, I told you, beam with the given loading. This is, I forgot to write last time, beam with the given loading. I forgot to write last time, you write here. Okay, over. Now, start. Take moment about A. Minus VB into L plus, see, total load will pass here. Plus W into 11L by 20 is the total load. How many times I told, I don't know. W into 11L by 20 is total load multiplied by from A to line of action of this total load through center of UDL is L by 5 plus half of 11L by 20 equal to 0. These all very, very thoroughly explained earlier. See, you can make out how systematically questions are solved in a perfect order. First, I will solve all single type of load. Then I will start combining the loading so that everything will be covered. I want these classes forever be a permanent reference for those who want to really learn. If not today, some other day. Okay, now see. Minus VB into L plus. Take your calculator. 1 by 5 plus 1 by 2 into 11 by 20. Calculate this number. Multiply by 11 by 20. It will come 209 by 800. This you have to practice in calculator. Then into W into L into one more L here, WL square. It has to be WL square because reaction will be in terms of WL. One L is here, okay, 0. Or minus become plus that side. VB equal to 209 by 800. WL square by L is there. WL is the answer. See here, reaction. Okay, now sigma V0 upward positive plus VA plus VB minus W into 11L by 20 total load equal to 0. Substitute VB 209 by 800 WL. So VA plus 209 by 800 WL minus W into 11L by 20 0, or take calculator. VA you substitute here. Minus 11 by 20, that side becomes plus 11 by 20 minus 209 by 800. If you calculate, you will get 231 by 800 WL. Enter here. Now observe something. This distance is L by 5. This is L by 4. Slightly out of scale. That means the load is little near, actually see here, little more. Okay. Now correct. Now better. The load is little near to support A. That's why support reaction at A came slightly more than support reaction at B. Over. Now, or see this question, you make a note here. Instead of all the struggling, directly one line answer possible. I told you. This I told you for you. You should refer part 2, lecture 36. Okay, see now. I'll show the calculation. A, B. Don't write all these things. You write loaded length. Referring to given sketch, write loaded length. 11L by 20, I told you already. Then, see, now you require the total load. How much? W into 11L by 20 is the total load. We want what is this distance, what is this distance. See, correctly now. How I got this distance, I will tell here. If this is L by 5, L by 4, light line make here 11L by 20. Okay, now from here to center of UDL, L by 5 plus half of 11L by 20. L by 5 plus half of 11L by 20 will give you 19 by 40L. Check the answer. 19 by 40L. 1 by 5 plus half of 11 by 20 is, yes, correct, 19 by 40L. Once it is 19 by 40L, that distance is L minus 19L by 40 is 21L by 40. Or, right here, you can write how you got it. See here. L by 4 plus half of 11L by 20. Okay, now direct answer. This reaction equal to load W into 11L by 20 into other distance. How much other distance? 21L by 40 divided by L. You will 100% get this answer. And this reaction is load into other distance, that is 90 into 19L by 40 divided by L. Simplify it, you will 100% get this answer. Very fast you get the answer. You write the answer here, equal to 231 by 800 WL. Here you write 209 by 800 WL. Very useful. Instead of taking moment, simplifying all not required, what you will do? See, I will tell once again now what to do. For the beam, see where is the total load. Mark distance from this end to that line of action. Mark from that side. Then this reaction equal to load into other distance by span. This reaction equal to load into once again other distance by span. I told so many endless number of times. Now I don't know why suddenly started raining. So next two more questions are there for numerical for UDL. I will wait for some time. I will pause. That's what I can do. You can't take out because I will pause and restart. There will be slight disturbance because light drizzling is going on. I think manageable. Okay. Question 19, dictated. A simply supported beam of span 15 meter is loaded by an UDL of 30 kilonewton per meter for a length of 10 meter starting at 2 meter from left end. Now, if this is 2, this is 10, this will be 3 meter. Later I will tell. Or question can be given, simply supported beam of span 15 meter loaded by UDL of 30 kN per meter, 10 meter long, starting at 3 meter from right end. Then when you calculate, this will become 2 meter. Or they can tell, simply supported beam of span 15 meter loaded by UDL of 30 kN per meter, starting at 2 meter from left end and ending at 3 meter from right end. Then using this data, you can find this 10 meter. But this is the given. Okay. This is the question. Rain is becoming heavy now. I have to pause. No. Question 19. I took a pause because of rain. I already dictated. If you want once again, simply supported beam of span 15 meter loaded by UDL of 30 kN per meter, 10 meter long, starting at 2 meter from left end. Okay, usual story. This is what, this last time question. Okay. Usual story. Put a neat sketch. VA, VB. 30 kN per meter for 10 meter. This is 2. Actually, this distance is not required. Right now, not required. But still, see, write it, what is there. From 15, subtract these 2, you get 3 meter. Take moment about A. Minus VB into 15. See, once again, every class I am telling. Total load. 30 into 10 is the total load multiplied by line of action of total load is through center of UDL. 2 plus half of 10 equal to 0. Simplify, you will get plus 140 kilonewton. Sigma V0 plus VA plus VB minus total load. 30 into 10. When you do sigma V0, only load. When you do sigma M0, load into distance equal to 0. Substitute VB, whatever you got, you get VA. Therefore, these are the reactions. Okay. Now, or instead of right here, all the struggling, directly you can get. How? Very useful. Part 2, lecture 36. Sketch the beam neatly. See, span is 15 meter. Write wherever you want. There is no place to write span here. Okay, somewhere here. Span 15 meter. Okay, 15 meter. I think it is visible. Now, 30 kN per meter for 10 meter. So, the total load is 30 into 10 kilonewton. Okay, now, line of action. Don't write anything now. See this question. Here, see. That resultant load will pass at center of UDL 2 meter plus half of 10. 2 plus half of 10 is 7 meter. Once this is 7 meter, you can tell 8 meter. Or this gap is 3 meter here. 3 plus 10 by 2, 8 meter. Actually, once you get one distance, other directly you can write. But still for checking purpose. Okay, now, this reaction equal to total load 30 into 10 multiplied by other distance 8 divided by 15 span 160. This reaction total load into other distance 7 by 15 140 kilonewton. I first thought I will do 20 questions. I mentally counted. Then I suddenly realized missing question. Okay, little interchange now. Okay, no problem. Question number 20. Actually, this should have come earlier. See, when you do partial UDL, earlier we first solved symmetrical, then unsymmetrical. Now numerically, unsymmetrical over, back to symmetrical. See, simply support beam, I will go one thing, okay, of span, some span, anything, of span 20 meter is loaded by UDL of 80 kilonewton per meter, comma, 80 kilonewton per meter, comma, ಒಂದು 12 meter long, symmetrically placed with respect to center. In the question given, symmetrically placed with respect to center. See, this is symmetrically placed means, correctly remember, if this is 12, you write here, this is the load, this is 20 and 12, you write word, UDL is symmetrically placed is given in the question. There is, I can't write in the numericals there, leave it. Make a note here, symmetrically loaded. Okay, over. That usual. Now see, how much UDL? 80 kilonewton per meter. Loaded length is how much? Load, I'll remove everything now. See, now earlier question. Loaded length is 12 meter. If it is 12 meter, I'll write here. See, loaded length is 12 meter. Space problem, okay. 12 meter loaded length. Let C be the center. Right here. Let C be center of beam. Center of beam. That means from here to C is total span is 20 meter, 10 meter and 10 meter. Right here. Now, you have to write a note here. I am dictating. Symmetrically placed with respect to center means exactly half the UDL this side and half the UDL this side. So this length is 6 meter, this length also 6 meter. Okay, start. minus VB into 20 as usual plus 80 kN per meter for 12 meter is the total load into directly 10 equal to 0. Or if you want, instead of 10, you can write this is 10 meter, this is 6 meter, that laughing part. 10 and 6 means this gap will be 4 meter. 4 plus 6, somebody will be laughing at you. Over. You got VB equal to 80 into 480 plus 480 correct, plus 480 kilonewton. Sigma V0, VA plus VB minus 80 into 12 is the total load equal to 0. Substitute VB equal to plus 480 kilonewton. You will get VA plus 480 minus, how much it is? Minus 196 minus 960 equal to 0. VA also will come plus 480 kilonewton. Therefore, right here, therefore, answer. Therefore, if you have a simply supported beam, see, neatly I will write. Simply supported beam, which has a span of 20 meter. Let C be the center of the beam. Center, right here. C is center of the beam. Center of the beam. UDL is symmetrically placed with respect to center. UDL length, total length is 12 meter with UDL 80 kilonewton per meter. When they tell center, surely this is 10 meter. This is 10 meter. And also symmetrically placed means of the 12 meter, this side is 6 meter, this side is 6 meter. In that case, your reaction at A and B will be as shown below. Your reaction VA equal to 480 kilonewton. See, now no plus because why? Direct answer, upward. VB also equal to 480 kilonewton. Okay. Now, after you write all these, span 20 meter right there, 20 meter span. Right here, on note. This much struggling is not required. Later, when you draw SFD, BMD or somewhere, if you get this case, we will not waste time. We will put directly due to symmetry or right here, due to symmetry, directly due to symmetry, vertical reaction at A in upward direction equal to vertical reaction at B in upward direction equal to total load on the beam, in downward direction divided by 2. This I am stopping now. See, action and reaction equal and opposite. So, whatever is the action, the sum of the reactions are equal. Symmetry is there, both reactions are equal. So this is 80 kN per meter for 12 meter equal to 80 kN per meter for 12 meter is the total load divided by 2 and internal 480 kilonewton. That is answer here. See, 480 and 480 kilonewton. Put that sketch once again. Whatever load is symmetrically applied, see, again, suppose this side you got a fixed end, that side you got a propped support, simple support, then you can't apply. Or if along with the UDL, if some other point loads or couples are there, then you cannot apply. Only for the symmetrical UDL, both reactions are equal. Even if one hinge, one roller given, that hinge horizontal reaction does not matter here. That we will ignore. Why? That has nothing to do with vertical load symmetry. This all we will discuss later. Now, question number 20 over. Now, next class, I will go for uniformly varying load. Systematic way, uniformly varying load. First bookwork, 0 to W, 0 to W, this way, and symmetrical load, isosceles triangle, then in general triangle, all bookworks next class. After that one, corresponding numericals. Then uniformly varying load for partial length, either left side or right side or central portion. We will cover all the possible cases of uniformly varying load. Once you completely finish it, we will change over to uniformly varying load represented by a trapezium. Once this way, once this way. First time full span, next time partial span. Their symmetry is not possible. After that, we will go for couples. Once couples are over, then we will go for combination of loads. There, plenty of questions. When I go for combination, I will not maintain order. Some order I will maintain. I will start from some questions. See, this is question 20 now for simply support beam. These are all standard cases. Till I finish the reaction, number will continue. I think by the end of this reaction for simply support beam or cantilever beam and also for overhanging beam, when it is over, surely the question number will cross 100. Yes, if you understand each and everything thoroughly, you will become real master. So everything study thoroughly, maximum possible knowledge. Okay, thank you. We'll meet in the next class.